physical vapor deposition, a very special technology to extend a life of tools or any various components, to give a beautiful and shiny color for luxury stuff, to replace gold in certain applications, to do antibacterial coatings, and even to be used for Olympic torches. This all is behind technology PVD. And today I'm in heart of this technology in a company Balzers, a part of Oerlikon Group, and having Denis Kurapov, one of the, I would say, well-established experts in this field, giving us an introduction.
So I make a short tour about applications we are covering with PVD within our company. So one of the biggest parts, of course, where we started with wear protective coatings is the cutting tools. So you see here many different varieties of cutting tools, so starting from drills and some end mills. Those tools used to produce gears, for example, for the gearboxes of the cars. So if you do the shift, speed shift in your car, so there are some wheels moving, so those wheels produced using those tools. We got also very tiny tools, like this one. So you might see, it's a micro drill. So for example, it's used to drill very small holes in the injection systems or in the watches or in medical instruments or some other. So another application is a forming tool. So for example, we coat special tools to produce aluminum cans, like drinks. If you buy a cola can or whatever, it might be produced with a tool coated by us, right? What you can also find in daily life is a plastic bottles or PET bottles. So they start the production of PET bottles done by, starting from this part. So first you produce this one and then you blow it to the bottle. And to produce this part, there's a special core pin used, and this pin coated by us to prevent sticking of the plastic on the tools. But the world of PVD is of course much bigger than only tools, right? So let's go and look what else can be coated. So here we are coming to the parts where we are talking about different components, like everywhere when it comes to the friction and wear, we apply coatings to protect surface from friction and wear. So here we see different parts coated with this coating, and this, for example, the injection for the diesel engine. So, and just by using coating, it was possible to increase injection pressure and to reduce consumption, fuel consumption, and increase efficiency of the motor. Of course, there are also some special parts you see, like here. What is it? As a special parts where the friction come in place, and it's good if it's coated. Here's an interesting example. Here is a very what we'd like to share. For example, these are parts coated by DLC, and what we can is experiment. Yeah? So we start with rotating them. This one uncoated, and you can just see what is the difference, right?
Mm-hmm. Denis, you just mentioned something very important, which made me even want to jump in and ask you.
Sure.
You just showed us sliding properties. I'm bad in this, yeah. How you do it?
Practice.
Practice make you a superhero. Damn. Let's try again.
Okay, I do it for you.
Denis, as you mentioned, very important topic. Depending on the coating, you can also change tribological properties in terms of sliding, and yes. You mentioned one abbreviation which is called DLC.
Yes.
Can you please explain us what does it mean?
Of course. I mean, DLC stands for diamond-like carbon, and basically this coating is made made of carbon, and it has, let's say, superior mechanical properties. That's why it's diamond-like. So it has high hardness, and additionally to high hardness, it has very low friction coefficient, And that's why this coating is used in many tribological applications. So everywhere where it's coming to the frictional contact, so two surfaces rubbing on each other, this coating comes to the application. And this is a simple example. So this one was uncoated one, you see, and this one is coated with DLC. So basically what we see in uncoated part, it stops rotating much earlier compared to the coated part. And this is because on the tip of the part and the counterpart, there is much less friction through the application of fixed coating. And this is just an example where you really clearly see the difference you achieve by applying the coating. So it's actually a very big application range. All the applications where you need to reduce friction, DLC usually widely used. So let's go and see which application else we can cover with PVD. And here we're coming actually to most interesting part, maybe for the applications you might see in the real or in the daily life. So come here. So what we see here, for example, as what we discussed in our previous video, is watch housing. So it's basically the part of the watches. And if you look on your watch, it might be coated. In many cases, it's just a black coating, so which is a diamond-like carbon coating, which has very high wear resistance, so it gives you nice gloss, and it prevents scratches on your watch parts. So basically, keep watches looking good for the long time. What else you might see is, for example, in your car, like loudspeaker and covers, which also looks like a metal one, but it might be plastic part coated by PVD coating and covered with lac. Keep them looking like a metal.
It's very interesting. In fact, it's very interesting that you can apply a PVD coating not only on metals. You can apply PVD coatings directly on plastics. So you can change their properties, improve their resistance, and also give them a very different color, which might also have some luxury effect. I was never aware that you can apply.
It's not about the wear resistance protection. It's just giving you a certain look.
Yeah, exactly. That's a luxury effect.
Yes,
yeah.
Yes.
So, but I was never aware that you really can apply PVD on plastics.
Yes, it's possible.
You surprised me, but wow, positive surprise.
What else can we show? For example, for medical instruments, like this one, torching people. Yeah, but basically, first of all, to give a certain functionality to the surface, for example, antibacterial coatings, or also to give the wear protective properties to the surface, coating implied on different parts, like for example, drills for the dental industry or for the bone drilling and so on, or like dental implants, having certain color to have aesthetic effects. Yeah. So here we have very interesting example is an Olympic torch from 24, coated with PVD coating, looking nice, right? And maybe also very interesting one, part of car, how it goes, cooler grill, basically also coated, and it gives you a certain, first of all, certain decorative effect, but also functionality. So PVD coating, because it's a very thin one, it's transparent for the radars and all the sensors installed behind of this part, and this gives, as I said, additional possibility to design the car and to give it certain, how to say, brains behind.
As you can see, PVD is quite widely used in our daily life. You have applications in medical, in cutting tools. You can put it even directly on plastic components. And of course, things like Olympic torch, it's pretty amazing realizing that the Oerlikon Balzers were present as a part of Olympic Games and everybody was running with this torch, keeping the fire of sport games. I hope you learned something interesting. You also enjoyed the company of Denis. Please feel free to ask questions, add your comments, and we will do another question series interviews with Denis if we have enough of your interesting questions. Thank you very much, and see you next time.
Not today.
No, actually one has
One
function.
works. One works.
Looks beautiful. Practice makes an expert.